Okay, we are going to deal today with oblique cylindrical hoppers. So the oblique cylindrical hoppers are composed of two half cylinders, of which one of both must be oblique with a flat triangle between them. So that's what we're going to do. So the drawing that I'm taking in the book is actually figure 4-5, and we have the dimension. So as usual, we start with our center line. Now from the center line, the base, so the front view, let's say the front view can start here. The front view can start here. Now the base is 100 millimeter diameter, so the scale is 1 to 5. 100 divided by 5 is 20, divided by 2 is 10. So I have to set up the compass to 10. Yeah, I've set up it already to 10. So it will start here. So this is the base. Now in the meantime, I want also to have the position of the top view or top elevation. Let's say this is the axis of the top elevation. So this side in top elevation, it will be a circle. It will be a circle. And for the meantime, I want to subdivide, because the circle will be subdivided. The semicircle will be subdivided like usual. Now the height of the hopper is 300 to scale is 60. 300 divided by 5 is 60. So this will be the end. Right. Okay, doesn't matter. All right. Let's see. This will be the end of, see, the side of hopper. Then the inclination here, it must be 30 degrees. So if it's 30 degrees, the other side is 60 degrees. So I use the 6 degrees to draw the side. Okay, so this is our upper. So the end of our upper. Let's see in just so I learn to see the end. So the end of the top elevation will be here. All right, now we're going to, so this actually this circle here, we subdivided, semicircle subdivided like usual. So we have 1, 2, 3, 4, 5, 6, and 7, right? Now this point here, we'll call it X going upward here, so it's the same as this X. Now we have to, as we still using parallel line method, so we'll draw parallel line upward. Okay, those are the parallel lines. Now this point here, the center here, we call it B. Okay, and on top this point here, we call it A on this side of the upper. So the top side of the upper, we have XA and FB there. Yeah. Now we need to project this line here. This side, once we reach the base, the lines must go parallel to this side. Now they must go parallel. Okay. So this point here, we call it C. So this is the triangle which is in two sizes. So we have CAB, which is very important the time we are going to do the development. Okay, now let's complete the top elevation. So remember, this is already 10 millimeters. All right, now from here to here to C side, actually to C side, if I can just, you'll see that so these are just a line that I'm drawing. This is from C. I don't want to go up to avoid having many lines. Okay, they just me draw it so that it will help you to understand. Yeah, so there it must be a half circle or semicircle. That is the shape of our hopper. This is the top of our hopper. All right. Okay, this is the top of our hopper. Yeah. Okay. So we going to letters. So let's draw write the letters. So this is point D. I don't know if we really have enough space here. This is D, this is E, then we have F. Yeah, that one is B. So F, B, F, E, and D. Okay, very important. So we have point C, point A. All right, now we can start our development. So how do we start the development? So we have our hopper. This is the front elevation, then we have the top elevation. We will start, you see, we have, let's look at here. Let's first understand this. You see, this is point A. If we bring A down, you see that I'm talking about the top of this line here. All right, this line here is what we are seeing as this. It's got this shape here. So we have a curve, straight line up to the axis, curve again, straight line. So if we have, this is point A, point AX, and we have C here, and we have C here. Why am I doing this? Because when we are doing the development, we'll start with X to A. You see, X to A, we'll take these dimensions here. Then from there, it will be this triangle here. All right, ACB. All right, after that we are here C. You see, from C to C again is a semicircle. Then because it's the same diameter, so we still need this dimension. That's why we'll be using when we are drawing our development. So we extend this line here. Okay, all right, let's say if our development will start here. So if it will start here, so we have point X. All right, look at here. So on top we have point X, and at the base, let me extend again. Okay, good. Now you see that on top we have point X, and at the base we have point 1. This is 1. Now here at the base we have this dimension, all right, and at the top the same. So this side on top is a semicircle, at the bottom is a semicircle. The dimensions are the same. So how do I get the dimensions? The subdivisions. This is too small, but it will fit. Just make sure that it is really perfect. Yeah. Okay. So I'll mark 3 times because we have 1 to 2, 2 to 3, and 3 to 4. So we can only draw it, like for instance at the base, because we are dealing with parallel lines. So you see that we have 1, 2, 3, 4. All right, we have 1, 2, 3, 4 at the base here. 1, 2, 3, 4, but the top here is X. You see X goes to A, X goes to A, X goes to A. See, X goes to A is at the top here, and the bottom is 1 to 4, 1 to 4, X to A, 1 to 4, X to A. Now I'm here, I want to draw this triangle. I have to draw the triangle. All right, so I need the triangle is BAC, because this point 4 actually coincides with point B. Right, so B is here, is this point O. So I need to take C, from A to C, from A to C, and from B to C, from B to C. You see where they meet, that is point C. So we have a point C here. We can join. So this is B to C. Right, now we are going to go with the projection lines from DEF. All right, we project them up to CB perpendicularly, then from there they will go up to C here horizontally. Then from there we'll draw them again perpendicularly to CB. Let's erase this one. Okay. There is the small ruler. The small ruler helps us to take the so all of them, I'm taking C. I'll draw a line perpendicular to CB. I have 1, 2, 3. I use the ruler to help me to have perpendicular. I'm trying my best. You see, I just coincide the line because yeah, perpendicular. Now here. Then come to F. Okay, you see from D perpendicular to C. Now from there I'll draw up to BC again. I'm projecting them up to BC. to BC. Okay, then yeah, the last one B is already there. Okay, now from there I'll draw perpendicular to C, all of them perpendicular to C. So I'll have, as I have 4 lines, I'll have again 4 lines perpendicular to C. There is a small ruler, so I still use again this small ruler to have me to draw perpendicular lines. You see all of them. I'll be taking here perpendicular to C. The first one. There are other small rulers with graduation both sides is the best, because you are using both sides to have perpendicular to the line. Now the last. Okay. Yeah. Now from here I have all my lines. So what I'll do now, I have to take this. Remember, this distance here is the same as here, because now we are almost here. We want to draw from C to C. You see, from T to C is a semicircle, so we subdivide with these dimensions here. Remember this dimension here, and this I took it from here, so I just want to take here, is easier. Add it already. Okay, now we have 1 2 3 4, 1 2 3 4, then we'll continue 5 6 7, 1 2 3 4, then you go 5 6 7, then after 7 we'll come again to 6, after 6 go to 5, after 5 we'll go to 4. So what we have here, we have, this is 5, that is 6, here is 6, I don't want to write on the line, then here is our 7, then there is 6, here is 5, then we have again 4. Okay, we have to do the same on top. We have to we'll draw the lines here exactly as we did here. So I'll extend BC, then I'll take all the lines perpendicular to BC, then I'll extend again this BC here, then I'll bring them up to BC, then I'll draw perpendicular again. You see here already we have our curve. We'll come to draw the curve later. Let's first go with the perpendicular. Extend, first we have to extend BC. Now we draw perpendicular lines. You see is DEF. We draw DEF perpendicular to BC. Because this line are parallel, this line is parallel. The second one, so these lines are parallel, so even the projections also must be parallel. Okay, now from C I'll go horizontal. Before that I have to extend again this side, and yeah, don't mind that. Let first extend this line. Okay, now all these 1 2 3 I'll draw perpendicular up to here, I mean horizontal. I'll draw them horizontally. Exactly the way we did with the bottom part. Okay. All right, again I have 4 intersection, 1 2 3 4. Then I'll draw them perpendicular the way I did here. I'll draw them again perpendicular to BC. So if you have a ruler with graduation both sides is the best. Mine is got only one side. Okay, so again you see we still have one. Now look at here. Now I'm on top. As I said, on top we have C. You see C going towards C. So going towards C is a semicircle, and this semicircle is the same as AXA. You see, so that's why we still take these dimension, the size dimensions that we have, the size here, and we'll continue. You see these sides, remember we took them on this the divisions on the half circle. That's what we use here all the way. So here again it will be from C, top. I'm coming back. Okay, now I can draw the curve. Now go 3 as usual to see if that will match, yeah. All of these, yes. Okay. 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 Take the long one to make it almost straight. All right. It fits here. Yeah, a bit of too much inaccuracy there. Yes. Yeah, already it doesn't work out. Too much inaccuracy. Okay. All right. On top there, the curve is not really good. Yeah, this side is much better. Okay, so then I can join this side. So we have ACB, ACB. Then we continue with this side. This is the bottom, that is the top. You see here, I missed, I'm a bit inaccurate because of the way I'm drawing the perpendicular to here. If I add that small ruler with graduation both side, and first you check it with your set square like this, you check it with your set square, and you see that this line on top coincide with the line at the bottom, then it gives you a good, because here is really it's a problem to get the line from here, because it's the corner is a bit, is not sharp, so that I'm missing. I'm use the other method. All right, from there, this point again is C. You see I have C. I can extend it. So this again is C. So this point is C is the one. Now this, you see B and 4, they coincide. So 4 here, we have again B. So if we have B and C, we can again work out this triangle. This the way we work out the other side. We have AC, so we'll take the distance from A to C. From A to C. This is our C. Then to C. Then E to A. Now let's take B to A. So where they intersect, that is the position of A. So I must go back there and extend. All right, I extend the arc. So this is point A. So BA. And CA. Now from here, it's perpendicular already here. You see here is perpendicular straight line, and from AX is perpendicular to AB. You see AX is perpendicular to AB. So I have AB. From AB I can draw perpendicular, then I can take and the line, this is already perpendicular, just extend it. This side, where is the small one? Doesn't work. Yeah, it works. Okay, it works. You can see it works. So if I add graduation both sides, I couldn't struggle like this. Okay, so I need what I need. You see 1 2 3 4 5 6 7 6 5 4, then I need 3 2 1, and I'm done. So I take again this. Now I'll measure only at the bottom side, then I'll use parallelism to draw a line on top. 3, 2, 1. So I have 3, 2, 1. That is the end. Now we draw parallel. Okay, so this is again my X. All right, see, so I have 1, 2, 3, 4, 5, 6 up to 7. I'm talking about this from A at the bottom. All right, because the way we open it, we started with XA, then we go to AC. I'm talking about on top here. You see, we start XA, then AC, then C, we turn again up to C, we turn up to C, then we come CA, and we go back to AX, we done. Now at the bottom here, we start with X here, you see. So 1, 2, 3, 4, 1, 2, 3, 4. Then from here, A, we continue 4, 5, 6, 7, 4, 5, 6, 7. Then we go 7, 5 up to 4, you see. Then come up again to 1. All right. So you can see that at the bottom here we have a circle. That's why we have a circle. If this circle here is 1 to 7, 7 to 1, that's why we have 1 to 7, 7 to 1 is this circle here, which is the base. Yeah. So this is the end of our drawing. Now it's your time to practice. Thank you. Bye.